Hello everyone. Today we're diving into how API work for domain services in our Devum platform. To keep things practical, we'll be continuing with our HR tutorial application. Now, instead of jumping straight into theory, let's look at a real use case so you can see API in action. First, we'll navigate to the Leave dashboard. So, till the time the dashboard loads, just take a moment to observe the layout here. Over here, click on Filter and then select Employee from the drop-down. Now, here's where things get interesting. As soon as we select an employee, the system dynamically filters and shows only those employees who have applied for leave in the selected month. For example, right now you can see Divya Menon and Ashok Kumar. That's because these are the only employees who have applied for leave for this particular month. But the real question is, how is this happening behind the scenes? Let's break it down and see how APIs are powering this functionality. All right, now let's get into the real action. Now, let's understand how we actually create this API using domain services. First, we'll navigate to Domain Services. Once we're there, go ahead and click on Add New API. Now, here you'll be prompted to enter the basic details. Start by giving your API a meaningful and relevant name, something that clearly represents its purpose. And along with that, make sure to add a clear description so that anyone working on this later can easily understand what this API is intended for. This also helps in maintaining clarity as your application grows. Once that's done, hit Continue. Now comes the configuration part. Here, we'll define the basic details of our API. So take your time and follow along on the screen. First, set the type name. For this example, we'll enter API. Next, add a group name. Let's call this HR API. Now, for the service name, we'll name it Monthly Leave API. Next, we need to choose the output type. Since we expect multiple records to be returned, go ahead and select Multiple. Now, for the method type, we'll select Post. This is because our API will be sending data through the request body. You'll also notice options like WebSocket and Aggregator. These are optional settings, so for this use case, we'll skip them. And that's it for the basic configuration. Now, next we have the method input parameters. Here, go ahead and click on it. And now we'll create an anonymous schema. Take your time here. We'll name this schema as Page Input. Now, let's start adding the fields one by one. First, add Department ID and set the data type as string. This field is optional. Next, add Start Date and choose the data type as Local Date. This is also optional. Now add the final field, End Date. Again, set the data type as Local Date and mark it as optional. All right, with this, we are done defining our input parameters. Now, go ahead and click on Continue. Now, let's define what this API will return. Let's see the output schema. Click on Method Return Type Data Items and create another schema called Page Output. Now, add the following fields. Employee name as string, which is optional. Employee ID as string is also optional. User ID as string. This is also optional. Once done, click Continue. All configurations are now in place. Now go ahead and save the service. Now comes the actual part, building the logic behind the API. To save our time, we have already written the logic for you. In this API, as our requirement is to retrieve the list of employees who have applied for leave in a selected month. So, first, we use the DB filter function to filter data from the HR_leave_apply schema. Here, we apply a filter on the from_date field using the range operator with the values method. Input params dot month underscore start date and method input params dot month underscore end date. Next, we use the get field values function to extract the employee ID from the filtered data obtained in the previous step. Here, we pass variable _1 as the input and select EMP_name as the field name. In the HR_leave_apply schema, EMP_name is a foreign key that references the employee schema. Therefore, the function returns the corresponding employee IDs. And variable _2 will contain the list of employee IDs in the form of a string array. After that, we again use the DB filter function to retrieve the employee details from the employee schema. In this step, we filter the ID field using the IN operator, with the employee IDs obtained from the previous function. This helps us fetch the corresponding employee records. Additionally, we have provided an optional filter based on department. The department ID is received as an input parameter. If the department ID is empty, we do not apply any department-based filtering. However, if a department ID is provided, we filter the employee list based on that department. To implement this logic, we first use the isEmpty function to check whether the department ID is provided as input. This function returns true if the value is empty and false if it contains a value. Then we use this result in the if-else function. If the department ID is empty, we return the complete filtered employee list obtained earlier. If the department ID is present, we apply an additional filter on the employee list based on the department and return the department-specific employee list. Once we obtain the final employee list, we use the map function to generate the response data. The employee list is passed as the input to the map function. Inside the map function, we use the back-end action response builder to construct the API response. During API creation, we defined the response fields as EMP_ID, EMP_name, and user_ID. All these values are available in the employee schema. Therefore, EMP_ID is assigned the value each_ID, EMP_name is assigned the value each.name, and user_ID is assigned the value each.user_ID. Finally, this data item response is returned from the map function using the return type function. At the end of the function flow, we return the complete response from the API using the return type function, which sends the structured employee data as the final output. All right, now that we've completed building our API logic, it's time to connect everything to the dashboard. For this, we'll navigate to the Leave dashboard page. Our goal here is to bind the API data to the employee drop-down list. First, select the employee drop-down on the screen. Once selected, you'll notice that the drop-down element is highlighted in the outline panel, since it's a drop-down component. Now, head over to the Properties panel. Inside Properties, go to Data Source and click on Add Data Source. From here, go ahead and select Fluent Service. This is essentially our domain service where all the API logic we created is configured. Now we'll choose the specific service. In this case, select Get Monthly Leave Employees. This is the service we created earlier for fetching employee leave data. And choose method Monthly Leave API. Once selected, click on Add Data Source. Now let's configure the input parameters. Click on Add Parameter. First, select Department ID. Click on Map. Now, in the Event Store, go ahead and click on the plus sign of the drop-down list. Take a moment here to look through the param mapping. Scroll down and click Department ID. You should see it appear in the list. Once it shows up, carefully select Department ID and then go ahead and click on Map to complete the configuration. Now, let's move on to adding the next parameter. Click Add Parameter. Now select Month Start Date. Click on Map, and this time in the search, look for Calendar. You can scroll through the list if needed until you find the calendar fields. Once you locate it, scroll down and select Start Date Time. Take a moment to confirm the correct field is selected, and then click on Map. Finally, close the mapping window. Now we'll repeat the same step for the month-end date. Take a moment here and click on Map. Once the mapping window opens, go ahead and navigate to the Calendar section. You can select End Date Time from the param mapping. Pause briefly to confirm the correct field. Now click on Map, and once that's done, go ahead and close the window. Now, let's take a moment to quickly understand what we've just done. So essentially, we are passing 3 inputs from the UI to our domain service. The department ID is coming from the drop-down selection. The start date is being picked from the calendar, and the end date is also coming from the calendar. All of these inputs are then sent to the API that we created earlier so that it can process the data accordingly. Now, once that's done, close the Properties panel. Right-click on the Employee drop-down and go to Data Binding. Here, select the field for display. We'll choose Employee Name. And that's it. Now your drop-down is dynamically populated using the API. This is how we connect the back-end logic with the UI, making everything dynamic and data-driven. All right, now that the binding is complete, let's see this in action. When we click on the employee drop-down, you can see that Ashok Kumar and Divya Menon are displayed. These are the employees who have applied for leave in the selected month. Now, let's change the month using the calendar. We'll select February. Now again, click on the employee drop-down. You'll notice that no employees are listed. This clearly means that, for the month of February, no employees have applied for leave. And this is exactly the use case we wanted to demonstrate. Dynamic filtering of employees based on the selected month, powered by our API. Finally, once everything is working as expected, go ahead and publish your changes. Thank you for watching.